Good morning, everyone. My name is Susanna Afonso, 20184, from Dempe College of Arts and Science, class first year BSc, and this is my second semester project. The title for the project is Law of Corresponding States. We have to know, before this, we have to know that this title comes under the topic thermodynamics, which is a branch of physics that deals with the relationship between heat and other forms of energy. Coming back to the topic, the title, that is Law of Corresponding States, let us understand what is it all about. So, according to the law of corresponding states, the equations of states for real gases are similar when these gases are expressed in reduced temperature, pressure, and volume at critical point. Okay, so it simply states that if two substances, consider substance A, substance B, have the same reduced pressure and same reduced temperature, then they should also have the same reduced volume. This thing was being stated by the famous physicist Johann van der Waal. That is, substances behave alike at the same reduced states. Substances at same reduced states are at corresponding states. Basically, what he's just trying to say is that the corresponding states, a state that van der Waals choose to use, is called the reduced state, which is based on the deviation of conditions of a substance from its own critical condition. Okay, so when the values of P, V, and T, that is pressure, volume, and temperature, are divided by their respective corresponding critical constants, values for reduced pressure, reduced volume, and reduced temperature is obtained, and they are as follows. So here, as you can see, PR, that is reduced pressure, is equal to P, that is pressure, upon PC, which is critical pressure. And I've labeled the equation as equation 1. Similarly, TR is equal to T upon TC, equation 2. Molar volume, reduced volume, is equal to molar volume upon molar critical volume, equation 3. Moving ahead, I'm just rearranging the equation to obtain P equals to PC into PR, which is equation 4. Same way, T is equal to TC into TR, equation 5. And V is equal to VC into VR. That's my equation 6. Now the next thing is, if PR is equal to TR is equal to VR, which is equal to 1, it means that the substance is at its critical condition. Whereas if we are beyond the critical conditions, it means that TR is greater than 1, PR is greater than 1. Similarly, VR is greater than 1. But, and by the same way, if all conditions are subcritical, then TR is less than 1, PR is less than 1, and VR is less than 1. So now, in order to derive the corresponding state equation, we have to begin from the van der Waals equation itself, which is P in the brackets P plus A upon V square, close the bracket, into another bracket which we can contain some V minus B, which is equal to RT. So this is the van der Waals equation, whereas the A that is there is equal to 27 by 64 into R square T square upon PC, which I have labeled it as 8 because we'll be needing this substitution of the values later ahead in our derivation. And similarly, B is equal to RTC upon 8PC, which I have numbered it as equation 9. So now I have just substituted the equations 4, 5, 6, 8, and 9 in equation 7. Basically, I'll just go back, and this is the thing, that is 4, 5, and 6, and this is my 7 and 8 and 9 in this 7th equation, that is the van der Waals equation. And that's how I have obtained the following thing, which is equation number 10, that is PC, the critical pressure, into reduced pressure, plus 27 RC R square TC square upon 64 PC into VC square into VR square, in the other brackets into VC into VR minus RTC upon 8PC, which equates to RTC into reduced temperature. Then in order to simplify the expression, let us use a critical molar volume, which is equal to 3 times RTC upon 8PC, which I labeled it as equation 11 in order because I'm going to be now next substituting 11 in equation 10. And here it is. So substituting equation 11 and 10, we get the following thing. That is PC into PR plus 27 RC square, R square into TC square. How do we get, and upon 64 into PC. Now the thing is, how do we get this 64 PC square? That's basically this VC is here in the denominator and it's raised to the power of 2. And since over here this 8 was, the 8 over here is in the denominator, whereas in the equation it will go in the numerator. So 8 into 8, 64, and PC square. That's how I got it over here. And then this will become 3 into 3, 9, R square, TC square, and VR square, that's in the same previous equation as well. And then you same way again substituted over here, R3 RTC upon 8PC into VR minus RTC upon 8PC, which equates to R into TC into reduced temperature. Now we need to simplify the equation, get it in the reduced form. So I have just simply first cancelled 9 with 27 to obtain 3. The R square TC square will get cancelled away, same with 64, and one of the PC which is in the denominator will get cancelled with one of the PC in the numerator, so the power from 2 will reduce to 1. And then here I've just cancelled RTC with the RTC from the right hand side of the equation, and that's how I obtain this further equation. The next thing, that is PC into PR plus 3PC, this PC just remains from here, upon this VR will come here back, into 1 by 8PC, and 3 times reduced volume minus 1 gives me reduced pressure, reduced temperature. Then what I have just done is I've just taken critical pressure outside common, okay, as you can see here, and I have then just simply just cancelled it over here. And next I have just taken this 8 on the right hand side, which gives me the following formula, that is reduced pressure plus 3 upon VR square, that is that reduced volume, into 3 times reduced volume minus 1, which gives me 8 times reduced temperature. And this is the equation of law of corresponding states. So as you can see in the equation, it means that the equation has no dependence on the identity of the gas. This reduced formula will give you the exact same temperature regardless of the identity of the gas. So I hope I have been successful in explaining the law of corresponding states and how we have derived the equation for it using Van der Waals equation. I just hope you all understood. Thank you all for watching. Have a great day.